Okay, let's go. Let me turn this light off. Okay. Disambiguate them hoes, yo, so we can get another overload that matches what we're trying to pass. Makes sense. Or we can just explicitly cast, but then we have to reap what we sow if the value gets fucked up during the explicit conversion. Yep, you convert X to be unsigned, but fucking watch out, buddy. You change X later and you convert that shit again. Mm-mm. Mm-mm. Yeah, it makes sense. You could also do that. Well, yeah, I mean, if you're doing a literal, but that's just a syntax thing. That's not like, that's, I mean, I'm assuming that we're passing objects. So if we pass an object, a named thing, or not a non-temporary object. So if we're passing a variable, and the type just doesn't match, we can either make a function, another overload that takes it, or we can cast the value. If it's a literal, then duh. I mean, the solution is just to update what type the literal is, and then it's fine. There's no conversion. You just have to make sure the value makes sense. Yeah, I mean, this is just kind of a duh. Each argument matches at least as well as the other functions. The function chosen is the one for which each argument is at least as good as the others, with at least one matching better. Gotcha. So you could have a function that takes an integer, and a boolean. And we could have another that takes an integer, and a long. And let's say, yeah, int versus int long. If I pass it 3 ints, then yeah, it's fine. It's an exact match. But I want to do 2 exact matches in each, but then a type conversion versus a numeric something. So yeah, we could do something to, or I could pass a float. Let's see. Yeah, I could pass a float, and one has a double, and the other has an int. So is the float going to be promoted to a double, or is it going to be numerically converted to an int? The answer should be no. Okay, so we'll say int. I'm not even gonna name them. Int double. This should be the function that should be the preferred overload. And that's void test. Int long. Okay. And honestly, this can be an int too. And so we will call this with 1, 2, and 3.0f. And the reason this isn't ambiguous is because one of these is preferred. Int, 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 int. Okay, same for these. This is a float. Float to an int. It's numeric conversion. Float to a double. Numeric promotion. Therefore, promotion is prioritized. First function is called. Cool. First overload. Yes, the function chosen is the one that's at least as good as the others, and with at least one that's better. And so if we had one that was sorry. If I had called a 1 and it required numeric conversion and promotion, and another required a user-defined and an exact match, then for the first one, both are better than the numeric or than the user-defined match. But so we're comparing numeric promotion and conversion to exact match and then a user-defined conversion. User-defined is like step 3 or 4. So it's exact and then, no, it's 4. It's exact and then promotion and then conversion and then finally that guy and then ellipse and then compiler error. So I guess it wouldn't be, so the point is that one function has to be at least as good as all the parameters of another. So it would have to have one thing better than the user-defined type, so conversion, exact match, or promotion, and the other would also have to be better than both. But in this case, the one with the user-defined type has, or the user-defined conversion, so like a class or an object, so like an instance of a class, I guess, converted to a number or something, converted to some sort of value, even though the other parameter is an exact match. We have ambiguity here because our other function is not better than, or is not at least as good in both parameters. It's actually worse in one because an exact match in function 2 is better than anything in the other. Unless it's an exact match, then they're even. Hey, boy. Okay. Cool. It must be better than all others and no, yes. So better, well, better than all functions for at least one parameter and no worse for any parameter. No parameter can be worse. Otherwise, it's ambiguous. Ambiguous. This is ambiguous. Ambiguous. Oh, Hodge twins. That's it. Yeah, it makes sense. So we can have. And one of these could take. If I call text with an integer, we could have one that takes, or an integer, so you could have an int and a float. We could have a bool and a float, or a bool and a double, and a character and a long double. And in this case, it was having an error because we didn't have enough arguments. This, here it is. But in this case, if we did 3 and 3, not ambiguous because this is an integer, so we get a direct match. And then this is 3, it gets numerically converted, numerically converted, numerically converted. So this is the same for all 3. And then the int is a direct match, so it's better. If this was instead, I don't know if I can even do a literal boolean. I could do 3 like that, and then it's a character, and then this one is favored because it's a direct match. If I did 3.0, now it's ambiguous then. And the reason is because sure, direct match, numeric conversion, numeric conversion, direct match. So these guys are not, this is worse than this, but this is better than this. So this is worse, this is better. Which means this is better, this is worse. Which means neither of these functions are better. And then we do character numeric conversions, we can do a long double numeric conversion. Okay, yeah, makes sense. There are conversion rules for determining which is the better choice based on superiority. A function has to be superior than another, just like an army would have to have at least as good troops on average, and something better in order to win. Terrain advantage or strategy or something. Morale. So in this case, you're doing a character and a character. Here, the character will be promoted to an int. So the first one will be A. So in this case, it's going to print A instead of B or C. Yeah, it's because the character matches all the way through, and then A is the character, which gets promoted to an int. These two would be conversions. This one is at least as good on both, but better on this one. Therefore, not ambiguous. A. Good. Character int. Cool. Deleting functions. So if we have we're printing an int, pass it this. Oh, we pass it a boolean though. So if we pass it 5, we get 5. If we pass it A, we think, oh, it's gonna print A, but instead it prints 97. Yes. And then we have true prints 1, not true. We would need bool alpha. And regardless, this is actually getting converted to an int, so I don't think it even matters. Cool. Well, the calls are questionable. Yeah, it'll do so because these are value preserving. Because numeric promotion is value preserving. Hence, no complaint. Boy. Deleting using the delete specifier? It looks like a long page. Surprised. Never heard of this. The assign it to be deleted specifier. If it matches the function call to a deleted function, it will halt compile error. Okay. So, really? So we just... So you do it in the declaration, huh? So we could have a function, have it be overloaded and only have it be callable in the event that there's like a direct match. So if I had other overloads that took other values, they had other parameters and took different arguments, and I marked those as delete, then it would only accept the specific type and error out. And this maybe is desired in some case instead of just handling the error and converting it. In this case, we're checking to make sure, hey, is the value of this? Because so far, I haven't checked. Yeah, so far I don't think there's been a way to be like, if type of this is this. Like, if this is a character, if this is an int. Well, in this case, it is. It's if this call doesn't match this argument, or if this call is deleted, we can just delete the arguments. So instead of calling a function and our values getting converted, values we don't want to be converted, we can just mark for deletion. So we can have test float and then void test int, and we do this for the for declaration. And we're going to call test with for and see what happens. Oh, referencing a deleted function. But if we instead say for f, here it should be 4.0 f to make it a float. What happens if we say the literal without invalid literal suffix, literal operator template not found? So the literal operator needs to follow something that actually matches the type. So we can't just say, hey, we can say one is long because there's no inherent type difference. Or if we go from, I don't think it's because it's value preserving. It's just that there's a difference between so what if we said for you? This is an American version. Is this just ambiguous? Yeah. Okay. I'm just tired. I gotta go to bed. Fuck. But now, starting tomorrow, I'll be back at my apartment, so I can sit at my computer, which means I can start doing this shit earlier. So I can just get home off work, boom, start programming straight away. Back to it, because when I have to get back home, or back to this fucking house, then feed dogs and shit, I want to say that, I'll be dedicated enough to just sit down and do my programming, but bro, like, I just start too late, or it just feels wonk. And I can't just sit down and then lock it in. I got these fucking couches and shit, man. There's no setup. I need my setup. Or at least I need to be in the right spot. And I need to be able to start early enough. I gotta get home on fucking time instead of driving all the way out here. I gotta take the dogs out and then fucking shower and then do shit. Now I'm starting at 6 instead of fucking, I don't know. Probably excuses, but whatever. Alright, got some shit done.